Welcome to ClickMyProject.com. Our project title is PWM-Controlled Series Resonant Converter for Universal Electric Vehicle Charging. Let us see about our project abstract. It is the possible of series resonant converter to the cover of a wide area. It is a high on fat efficiency curve. As the voltage increase, the secondary side is rectifiers. It is a proposed converter of greatly convert from the full bridge rectifiers to the voltage doubler rectifiers. It is a full bridge rectifier to the voltage double rectifier is the proposed one. Since the switching frequency is the resonant frequency is the boost mode, is a proposed method is a two peak efficiency point with the full bridge and voltage doubler rectifiers. After that is a drop over wide range of gain, and then reason for proposed is high and fault efficiency of curve, and then proposed converter is design the control the verified as a 800 watt and input is a 200 to 950 of volt is the output prototype. This is the project flow explanation. The first of all is the DC voltage connected to the clumping capacitor, and then after to the switches of two. It is QP1, QP2, and then after to the transformer connected. The switches are gate pulse generated for the PWM pulse. The PWM pulse is a pulse width modulation. It is generated the gate pulse of switch 1 and switch 2. After that is a transformer connected with the half bridge rectifier. Half bridge rectifier is the QSR1 and QSR2. After that overall is the load resistance, capacitance and the resistor will be connected. So overall process is the PWM pulse generator. PWM pulse is a module of 3 sine wave and 1 sawtooth wave is generated to the NOT gate. After that is generated the sine tooth waves. The QSR1 is the T on, QSR2 is the T off. After that the QP1 is the T on and QP2 is the T off. This DC voltage is connected to the two switches is through to the gate switches, gate pulse. After to the linear transformer connector, it is the PWM pulse generation. This is the PWM pulse generation. It's a 3 sine wave and 1 short tooth wave generated. Is the condition of NOT gate. After that, the signal generated through to the switches of pulse is the PWM generation to go to the gate switches. I will run the code. It is a time taken for 10.0 is a compiling time for 100 percentage. It is compile time is 100 percentage. After that I will show the output. This is a 3 sine wave is generator, 1 short tooth wave is generator. This is the input of pulse. It after to the conditions is this is a Q of AP1. This is a Q of AP2. This is a PWM pulse generation. This is a T off, this is a T on, this is a T on, this is a T off. This is the opposite direction. This is a QRS1 of switches. This is a T on. This is a T off. This is a I naught of value. The gate pulse generated for 4 switches. This is the output of waveform. This is the output of waveform. The 600 or 800 reach the output.